So what we're going to do is setting up to solve. We will learn how to interpret questions based on real world examples. So the idea is today's lesson is all about how can we read a question and use that question to set up an equation that we can solve. And it's really good to do this idea of interpreting, understanding what is written and taking a written sentence and converting into equations. Now the reason why, the only difference here that I've tried to do is I've said real world examples. If we look back at these examples that I did here, so this is backwards, a 4th is removed and a 13 is removed from a number. These are not really applicable to real world examples. These are just like algebra fun things. What I'm going to be doing is I'm going to give you guys worded questions that are based on like sort of not really like sort of more real world applications and how we can do it. They range from easy to difficult, and they're supposed to give you guys a little bit of an idea of how to solve the questions in specifically 3D. This is supposed to help you out with 3D. So 3C and 3D is going to be what I'm going to be setting for homework. Let's grab a look. Anthony owns a hybrid car that can drive 70 kilometers on the battery alone, and then can drive 16 kilometers per liter of fuel. How much fuel will Anthony need to drive at least 400 kilometers? Okay, so let's underline some of the things that are important. 70 kilometers, that's important. 16 kilometers per liter is also important. Now, what we need to do with a question like this, how I usually like to start, and then the question actually asks for, we want to go at least 400 kilometers. So how I usually start with a question like this might be to say, well, what are my variables? Can I get someone either out loud or in the chat to tell me what are the variables that we're dealing with in this question? What are the things that can change? Waiting on you guys. So what's something we can change in this question, or what's something that does get changed in this question?
The liter of fuel.
Liters of fuel?
Yeah.
Yeah, so we've got like the amount of fuel. Whoa, that is definitely one of our variables. That is something that can change, the amount of fuel. We're going to use the symbol F for fuel. Is there another thing that can change that is affected by this or something? Aside from fuel?
Kilometers, I think.
Kilometers? Yeah, the kilometers we move. I'm going to refer to this as maybe distance. So the kilometers, or we're going to call this the distance. Let's use the symbol D. Now, in a question like this, I would say, well, we are changing the amount of fuel, and that's changing the distance that we can travel. So that would make this one the independent variable, and this one the dependent variable. Okay, and you guys might remember that a little bit more from science than maybe maths, but yeah, the dependent variable is going to be our y, and our independent variable is going to be our f, or our x. So what we're going to do is we're going to try to now use these two symbols to create an equation. The distance that we can travel, well, we know we can always travel 70 kilometers because that's how much we've got in the battery. Even if we have no fuel in the battery, even if no fuel in the car, we can still travel 70 kilometers. But we can, on the battery alone, but then we can drive 16 kilometers per liter of fuel. Now, just like last time, I hope you guys remember, whenever you see the word per, you should think there is a multiplication here. In this case, there is. 16 kilometers per liter of fuel. So that means we can go 16 kilometers for every 1 liter of fuel. So if I go 16 times F, that means that if I was going 1 kilometer, if I had 1 liter of fuel, I could go 86 kilometers. If I had 10 liters of fuel, I could go 160 plus 70 kilometers, which is 230. So this is our formula. And you will usually find your linear formulas will make this kind of form. You'll have some kind of constant and then some kind of variable that changes. And that might be plus or it might be minus. But in this question, we actually know how far we want to get. We want to go 400 kilometers. That's what we want D to be. So 400 equals 70 plus 16F. Okay, let's get F on its own. So we'll subtract 70 from both sides. So that would be 330 equals 16F. Let's get rid of this 16 by dividing both sides by 16. 330 divided by 16 is 20.6. 20.6 liters. We can write a sentence for this if we wanted to, with at least 20.6 liters, he can travel 400 kilometers. So if he had more than that, he could travel further. Let's break this down step by step one more time. So first thing what we did was we underlined the key ideas. The second thing we did was we created variables. And so usually you'll figure, and you want to know out of the created variables, which one's the one that we can change? We can change the amount of fuel, and which one is the one that gets changed because of that changes, the distance that we travel. After you've picked your variables, you can then create an equation. And then the last part is to solve that equation. So this is sort of the steps that I would go through to try and solve it. I'm going to refer to this as a single variable example because the next one is going to have more than one variable. Am I good to move on? And do you guys want me to re-explain something or something, or you know, go back over this? I'm going to look in chat to see if you guys saying that you want me to go back over it or if we're all good. I can move on. We're moving on. Okay. This next one is example 2 out of 3, which means we're pretty much halfway there. Pierce has 3 children and 2 stepchildren. In his will, he gives each stepchild as much. He gives each in his will, he gives each stepchild half as much as each of his children. Oh my God. Because he's a jerk. If Pierce has 200,000 to give to all his children, how much does each child get? So his full children, you know, they get, you know, the full amount, but his stepchildren, right? So we can firstly, he has his 3 children and 2 stepchildren. He gives each stepchild half as much as each of his children. Okay, so how can we write that down? Well, again, we're going to have to have this idea of, okay, well, let's think of a variable. The variable that I'm going to use is C. So C is the money given to his children. So that means his stepchildren or stepkids only get half that. So we can now figure out how much money there is in total. So we've got 3 stepchildren. Well, we've got 3 children, and we've got 2 stepchildren. And all of these children, when you add them all together, when you add up all the money that they each get, that needs to equal $200,000. Okay. Now, if we then simplify this, this becomes 4C equals 200,000, which means that C equals $50,000. So that means that each child gets 50,000, and each stepchild gets 25,000. Now, how this question sort of is broken down, the reason this question is a little bit different to the other question is we're using the same variable twice. We're using the amount of money that each child gets, and then we're using that again to figure out the amount of money that each stepchild gets. I'll be honest with you, I have not written this question very well. I think I needed to change it around to make it a little bit clearer, maybe giving some more context about why he's being a jerk for. But yeah, that's in general how I would solve a question like this. The reason why I knew that this is a 3 and this is a 2 is because I based it off the information at the top. This is a bit of a weird question, but yeah, it's sort of trying to give you an idea of a different way that you might get questions. Yeah. Okay, cool. That's fine. That's just Baden. I've got one more example. Do you guys want me to go? Can I move on to the last example, or do you guys want me to re-explain how I did this? Will this question be on the test? This specific question? No. But something like it potentially. I'll show you what I mean in a bit. It's not going to be exactly the same, but I'll show you. But otherwise, can I move on to the next one and I'll show you one more? Okay, we're going to move on to the last one. The last example here is a bit of there's only one question like this on the there's only one question on this on the in 3D, but I wanted to talk to you guys about it anyway. Arthur and his brother Tommy are building towers out of Lego. Okay, Arthur uses 10 bricks per minute, so whereas Tommy uses 8 bricks per minute. Okay, if there are 504 bricks in total, how long will it take for them to run out of bricks? Okay, so here's the question for you guys. Can someone tell me what the variables are that we're looking at in this question? Or one of the variables? Minutes. Perfect. Correct, Logan. You are right. I'm going to use the word T for time because minutes are a measure of time. And yeah, we're going to use the symbol T because that's going to be our symbol here. Anyone know what another variable is? That happens to be our by the way, independent variable. That's the variable that changes. What's the other variable? Bricks, the amount of bricks. Beautiful, bricks. And that's going to be a dependent variable. So the amount of bricks that are being used, right? The amount of bricks that are going to be used are going to be equal to, well, how many bricks? Well, Arthur uses 10 bricks per minute, per being time. So we've got Arthur using 10 bricks per minute. And then we've got Tommy, he's using 8 bricks per minute. Right? And that's how many bricks have been used up after T minutes. What can I do with this idea? What can I do with this idea here? Now that I've got, this is how many bricks are being used. What can I do with this? Does anyone know? Simplify. Beautiful. Thanks, Mayuri. I can simplify this by adding them, which means that I know that 18 bricks gets used every minute. So if there are 504 bricks, and I know that 18 bricks gets used every minute, I can divide both sides by 18 to find out that there are 28. After 28 minutes, all of the bricks are used up. Okay, cool. All right, now the last question. How many bricks do they each use? Well, we can actually use this information to answer this question here. Let's start with Arthur, right? Arthur's using 10 bricks per minute, right? So if he's got 28 minutes, he's got 10 bricks per 28 minutes. So that means Arthur's going to use 280 bricks. Okay? Whereas his brother, Tommy's a bit slower. He usually uses 8 bricks per minute, which is going to be 8 times 28. So 8 times 28, 224. If you add, just as a quick point over here, 224 plus 280, well, that's going to give you 508. Yay, it works. So so let's go back over what we did for this one. Same thing we did with the first one and a little bit the second one. We chose our variables, our independent variable and our dependent variable. We create an equation. After we create an equation, we then solve the equation. All we're doing here is we're using that information. There's a question. I think there might be a question. There is something in chat. 508. What did I do? 504. Okay. Yeah, why did that equal 500? Why did this equal 504? I made a mistake. I may have made a mistake. Let's see if you guys have, what are you saying in chat? Have you guys figured out my mistake? Yeah, it's 504. Sarah, I think you added wrong. 224 plus 280 is 504. Yeah, I know. And I'm trying to figure out why I did that wrong. 8 times 28, is that? $224. 10 times 28, 280. Oh, yeah, hold on. Here we go. Here's the challenge. Can you find out where Mr. Greer made a mistake? I just
made
added. Just right at the end. Yeah, I know. I get that wrong. But, oh no, sorry. I can't read the damn question. Yeah, okay. Sorry. Yeah, I had a moment. Don't ask. Oh, it's because I saw the 8. Okay, sorry, Mr. Greer's an idiot. That's all right. It's fine. Okay. Okay. Let's move on. What I was really confused was I was like, it's supposed to be 508. Then I looked back over at the 508 part and I was like, oh wait, no, it's supposed to be 504. What I want to show you guys to wrap up with, and this is pretty much it. I want to briefly talk about this. So this is 3D. You can see in 3D at the start, there's a lot of these questions about perimeter, you know, whatever, we've just done those types of questions. There's a bunch of these questions about 7+, and then the last few questions are the ones we've done today. A raffle prize, so go look at question 10 here. So the first two here, this is very similar to our electric car question. 11 students want to run a social club. Cost of hiring a band is $820. They're selling tickets at $15 per person. All right, cool. So then 15 times P. You can use that to figure out, you know, roughly it's the same sort of maths. Question 10 is a little bit like our middle one. A raffle prize of $1,000 is divided among Anne and Barry. Anne receives 3 times as much as Barry. How much does each receive? Well, Barry would be the price that Barry, so it would be B would be the price that Barry got, and Anne would be 3B. So B plus 3B, that's going to equal $1,000. The last question that I showed you, and this is similar to Bruce here in question 11. Bruce cycles X kilometers and then walks what this last bit here is very similar. Bruce cycles X kilometers, then walks half as far as he cycled. So that's X divided by 2. And so therefore the total distance covered is 1.5X. So then you can use that. That last question that we did about the bricks is actually very similar to this question here. Okay, it doesn't look like it, but it is. A lot of students struggle with this question, and I know some of you will too. So if you struggle, I want you to let me know, and I'm more than willing to explain how to do this question. Right.